We've seen how we can use functions to evaluate the dependent variable at different values of the independent variable. We've looked repeatedly at the function h of t, which measures the height of a thrown rock off a cliff at different times t. As we study functions, we don't always just want to know where the function is at different values of t or x. We might also want to understand how a function is changing or how rapidly the function is changing between 2 points. That is called an average rate of change. So our function passes through the points 120 and the point 30. We can see that it decreases about 20 meters over a span of 2 seconds. So the average rate of change is about negative 10 meters per second. It goes down 20 meters over 2 seconds. That measurement in real life is called the average speed of the rock, or how rapidly the function is rising or falling, how fast it's rising or how fast it's falling. So we measured the delta y, or how much the y changes, over how much the x changes. That is how we calculate an average rate of change. But we do that between any 2 points. We could have chosen 120 and 30. We could have chose 0.15 and 120. This line that passes between these 2 points is called the secant line. And so the slope of that line is also known as the rate of change. So the slope of the secant line is the same as the average rate of change. We can calculate the slope of the secant as delta y over delta x, or in a more expanded and more useful formula, f at x2 minus f at x1 over x2 minus x1. Let's use that formula here to find the average rate of change of x squared from x is equal 1 to 4. We'll take the formula for a rock. Average rate of change is f at x2 minus f at x1 over x2 minus x1. Which is our x2 and which is our x1? x1 is here. It's the value 1. x2 is the second value, so 4. So we'll sub in 4 for here. We get f at 4 minus f at 1 all over 4 minus 1. And now how do we find f at 4? We sub 4 into the function. So we get 4 squared minus 1 squared over 4 minus 1. 4 squared is 16, minus 1 is 15. Sorry, forgot the 1 here. Divided by 3, so 15 over 3 is 5. The function is changing at a rate of 5 between x is equal 1 and x is equal to 4. What else is this known as? This is the slope of the secant line. So in the secant line that passes between x is equal to 1 and x is equal to 4 for the function f at x is equal to x squared, we can find the equation of that secant line. How do you find equation of lines? The same way you always have. You need a slope and then you need a point. So the slope we have already. We need another point. Do we have it? Not really. We have 2 x values. But you know that you can always find the y value by subbing it into the function. So let's choose the less complicated point. Let's choose 1. When we sub 1 into here, we get 1. So that tells us that 1, 1 is on our line. Also, we know that the slope of our line is 5. So how do you find the slope of the secant line? Simply sub it into y is equal to mx plus b and solve for b. So we'll sub in our slope into here. We'll sub in our point into here. We get 1 is equal to 5 times 1 plus b. When you solve for b, you get negative 4. So the slope of our secant line is y is equal to 5x minus 4.